Hi everyone, let me introduce a new variant, the U-blade Dozer. This is the variable angle and this is the U-blade. And finally, this is the video number 3 of this assembly and the final assembly for the U-blade Dozer. Here, if you 3D print the tracks, you can expect 6 kilograms of weight. And if you use the metal ones, you can expect 7 kilograms of weight. On the new variant, I'm going to be including also the heavy duty blade. This is the lightweight, and this part on the cover, the protection for the cabin. And the people that have bought my variant angle version will have this version for free. Let's go now and focus on the finished assembly for the U-blade version. On the previous video, I was saying that this blade version was having an issue because this thing was fixed here. It was not pivoting this way when I was varying the angle this way. So I came up with the next version, and it's here. I have not painted it yet, but you see here, there are some screws here, and these screws will hold these anchors that are for the ones included in all these actuators. They include at least 2 for each actuator, so I'm going to reuse that for this improvement. Another improvement that I have made is reusing these end ball joints, and they have a pivot point here, and what I did is using some pliers, I make pressing this way, and I took it out like this. So now I have this component here, and what I do is I press fit in here because I make the same design that this piece has, and then we press fit in here. I can use this tool also for doing this part. I think it's way easier, but you can also do it with pliers. And then it's there. And if I put this screw here, it's going to pivot also this way. So you have all the pivot functions here, and it doesn't move out of there because it's doing the same function. And it looks really nice and functional. I like this solution. Super great idea of reusing the components for the other version, so we can have common components here. Is using this joint ball, I put it here, and now it can pivot also this way. So we tie these screws, and then it's going to create a joint with the pivotal point for controlling the arm of the blade. And it works awesome. So I'm going to assemble everything and then test it to see how it goes. And I think it's because they are too tight. I'm going to make this hole a little bit bigger. So for these two components to resist the pressure on this part here. Now I'm happy with the results here. Finally, it's working good. You can see the variable angle here. This is the other angle lower. Let me show you this mechanism. And this is how it pivots. And over there we have all those joints and working all together. Really nice. Of course, I had to paint all this one, but I can proceed now with the assembly. And now, only for a demonstration, let's organize the workbench with the Bulldozer. Clean and organized. I will also show you the travel from the top to the bottom part of the plate. Still there is a little bit more there. And then back to the top. These are the materials that we need for the front spotlights. This is a 100 ohm resistor, 2 LEDs, and the case with some screws. Here I have connected these 2 LEDs in parallel, and we put it inside here. Then we have this plastic that we cut before, and then we assemble the spotlight. Put it here again. This one. With another screw. Close this part. So these are the 2 LEDs in parallel. They need a resistor. In this case, I'm going to put a 100 ohm resistor here on the cable. Okay, we have this now. It's going to be located there. I'm going to assemble now the details for the engine cover. A quick note with some changes with respect to the metal tracks and the 3D printed tracks. Previously, I was having two versions of the undercarrier, one for the 3D printer tracks and one for the metal tracks. And that was because these two has a different width. The metal tracks are wider than this one by 2 millimeters, as you can see here. But it's not that much. So in this version, when I'm releasing these files, I'm going to merge these two versions into only one undercarrier that is going to be wider for this one, and I'm going to make wider a little bit the 3D printed ones. For all these wires for the lights, I have to put their corresponding connectors, and for that I have bought these two. It's a crimping press. The process consists on having these metal pieces going here, and then you press with this tool and crimping those connectors here, and then once it's done, you slice into this jacket, and that's it. Another really annoying thing that I have with these connectors, when I made these connectors from scratch, is that these pins, the female pins, it has some stick out here that secure this jacket when it goes here. But apparently they made these connectors on, there is no a good standard for these connectors. And what is happening is when it's inside this jacket and the cable is connected, and then I put it inside to get the pin, this pop up here. So it's not securing this part here. And I have tried it, put it in this way, reverse and forward, and it's not working. So if you guys know a way to fix this issue or which one to get to avoid having that problem, just let me know in the comments. And I will not be recommending this crimping press that I bought on Amazon because it has this issue that it came with all these connectors that are worthless, because it's really annoying that when you connect this one here, it pop up. So yeah, we have all the connectors here ready, and we only have to plug it now on the corresponding. This rail is for lights, this is for speakers, and this is for the S bus or I bus. And lastly, for the sound model and to control all the functions, I have downloaded the software and reassigned the channels for the sound model. So the issue with this controller here is that when you configure the exponentials, they only allow you to assign exponentials. So the exponential and rates is only allowed to this channel 1, 2, and 4. So it doesn't allow you to put exponential channels in these buttons here. So that way that if you move this one and you have the exponential, the end strings here will be 75 and 75. And then if I move this one, the ends is going to be 100% and 100%. So it's exponentials applied to this switch here. And I don't know why it cannot be, they don't allow you to put other stuff here. In this other remote control that I have, the Radiomaster TX16S, you see here all the monitors and all the channels. And this is my dual rate. I think, see. So you see here 100%. And then it's 75. So this is my dual rate that I have assigned here. So here is 75, and then when I put it up, it's 100% of this switch here, and this one, yeah, also on this one. So I changed the dual rate for these ones here, based on this one. And that is what allow me to use multiple functions like lights and starting the engine and all of that. And I cannot do that in this one, because with this one I will move the blade and I will not be starting the engine and changing the lights, like turning the lights on and off when I move the blade. So if the DIY guy wants to connect, we can connect and see how to fix that in another version, or you can ask him. I will leave the link to his YouTube channel and also to the GitHub, where he has the software version for that. But with this guy, I can control all the tracks, blade and movement and everything. But now I'm going to use this one, since I can use the lights and sounds for the demonstration. By the way, this is like the previous version of the TX16, and there is a new version. So this one should be cheaper now. And there is another one that is the Boxer, and it doesn't have title screens here, but it's cheaper. And I don't know if it should allow also that, because it's run the same software. So you can assign exponentials to these ones instead of these ones. I will recommend if you're going to buy a radio, this is good, but it's limited. This will allow you to do more stuff and customizations and all crazy stuff. So let's continue with the assembly and the demonstration. To install the cabin ward, we have to assemble these pieces here. And optionally, you have also the complete roof that you can put here. But in my case, I'm going to leave it without the roof. Let's now include the driver. So we open the door here. We can put the driver inside. Little body there. connecting the battery is that we put down the blade further down, so these actuators can go a little bit further. Then we open this, we take the engine cover, and this is the battery. The connector here. We put the engine cover back again. And the cabin protection. And that was the demonstration for the semi-universal blade Dozer version that I have. Is now available together on the same files that the variable angle version is. So I hope you guys enjoy this new version for the people that already have the files, and for the new ones that are going to buy the Bulldozer, these two versions are going to be included. Some people said that they don't see my models pushing dirt, so I have to do more videos about these two guys working and pushing dirt. They are really capable, so that will be something that I have to work on the next videos, and you will see them in action. Thank you a lot for your support. Please let me know any comments or additional questions that you have below in the comments. And I hope you guys enjoyed this new version, and thank you for supporting me during all this time, buying my models and subscribing and liking to the videos on my YouTube channel. I will have new projects on the future, so please subscribe to the channels and join to the Facebook group if you want to be notified when I release new models or versions or videos. Till then, thank you very much, and I will see you on the next video.